Hi everyone, today we're going to head and go over lesson 5-3, which is polynomial functions. So the first thing we're going to take a look at is degrees and leading coefficients. So this is to state the degree and the leading coefficient of 7z cubed minus 4z squared plus z. And if it's not a polynomial in one variable, explain why. So what we're going to look here is, since this is in standard form, that helps out a lot. A degree is the highest exponent of the expression, and the leading coefficient is the coefficient attached to the term of the highest degree. And the reason it's called a leading coefficient is because if you write it in standard form, it leads the expression. So here, this is my highest exponent is 3, so this would be degree 3. And then my leading coefficient is 7. So here we have another example. This one's not going to be a polynomial in one variable, mainly because right here we have a and b. We have two variables, so it's not one variable. Next, we have 3x to the 5th plus 2x squared minus 4 minus 8x to the 6th. This one's not in standard form, so you have to go find the highest exponent, so which is going to be 6. So I'm only going to look at this term here. So my degree is 6, and my leading coefficient is going to be -8. It is easier if it is written in standard form for us to go ahead and fix it to identify it, but if it's not, that's the only thing you have to do is look for the highest exponent and the coefficient attached to it. All right, go ahead and pause the video to try this one out. All right, if you did it, you should have gotten B. My highest exponent is 3, and the coefficient is 3 for that term. All right, pause the video and try this problem. All right, so with this, it is not one variable because we have x, y here. All right, pause the video and try this one. All right, so our highest exponent is 7, and our leading coefficient is going to be -5. So our answer is B. All right, so here we have evaluate a polynomial function. The volume of air in the lungs during a 5-second respiratory cycle can be modeled by V of t equals -0.37 t cubed plus 0.152 t squared plus 0.173 t, where V is the volume in liters and t is the time in seconds. This model is an example of a polynomial function. Find the volume of the air in the lungs 1.5 seconds into the respiratory cycle. So all that means is everywhere I see a t, we're going to substitute with 1.5. So we take our original function and substitute in 1.5 for t. And we're going to head and simplify. And then we end up with 0.4766 liters of air in the lungs, about 1.5 seconds into the cycle. All right, go ahead and pause the video and try this one. All right, so here we have a toy rocket during a 2.35 second flight is predicted by the function h of t equals -4t cubed plus 6t squared plus 8t, where h is the height in meters and t is the time in seconds. This model is an example of a polynomial function. Find the height of the rocket 1.25 seconds into the flight. So all we would do here is everywhere I see t, I would replace with 1.25. I would go ahead and do that, and I would go ahead and simplify, and you should get about 11.6 meters. So we can also do function values of variables, meaning instead of just plugging in a number, I could plug in an expression. So in this case, we have b of 2x minus 1 and 3 minus 3 of b of x if b of m equals 2m squared plus m minus 1. So all that means, instead of writing an m, I'm going to write 2x minus 1 everywhere I see m. So then we go ahead and simplify. So we get 8x squared minus 8x plus 2 plus 2x minus 1 minus 1. And when we combine our like terms, we get 8x squared minus 6x. Then we're going to head and do 3 times b of x. So I'm going to do 3 times everything after plugging in x. And when we do that, we get 6x squared plus 3x minus 3. And we're going to take those two expressions that we just received and subtract the two. We're going to distribute the negative sign and then simplify to get 2x squared minus 9x plus 3. All right, go ahead, pause the video. All right, so with this one, when you work it out, you should simplify to be 2x squared plus 4x minus 2. Next thing we're going to take a look at is end behavior. So go ahead and pause the video so you have time to go ahead and write this down. It is actually a very useful table to have. All right, so we have two types of degrees. We have either even or odd. So here are evens, here are odds. Now we take a look at, is it a positive coefficient or a negative leading coefficient? And this basically tells me if it's right side up or upside down. And the end behavior follows for evens that your end behavior as you go left and right is going to be the same. If it's a leading coefficient that's positive, they're both going to be going up. If the leading coefficient is negative, they're both going to point down. And all of these, our domains can be all real numbers, but in even functions, we have a limitation on our range. If we have an odd function, here's positive odd and positive negative. Odd negative. If it's an odd function with a positive leading coefficient, it's going to fall to the left and rise to the right. So as we go to as f of x approaches negative infinity, x approaches negative infinity. As f of x approaches positive infinity, x approaches positive infinity. If we have a negative leading coefficient, it rises to the left and falls to the right. So odd degree functions will always have an odd number of real zeros. Even degree functions will always have an even number of real zeros or no real zeros at all. So for example, one thing we could take a look at is when we have a quadratic. So we talk about the roots. It can cross twice. It could cross never. And then we say we crossed once when, if I can get this just right, what we have here, when it touches and goes back up at once, it's called a double root, so it actually touches twice. We just count it as one answer, though. So looking here at this graph, we're going to describe the end behavior, determine if it represents an even or odd function, and state the number of real zeros. So we can tell based on my end behavior, it falls to the left and falls to the right. I can see it never touches the x-axis, so there's 0 real zeros. And because my end behavior is the same in both directions, I do know it is an even degree. And again, pause the video as needed. All right, so here is our second graph. Describe the end behavior. Is it even or odd? And the number is zeros. I can see it falls to the left and rises to the right. I know since we have opposite directions in our end behavior, it is an odd function and it has one real zero. And again, pause the video as needed. All right, go ahead and pause the video to answer this question. All right, so we can tell that it is an even function because my end behavior is going the same direction for both left and right. And I can see that I have two real zeros. So my answer would be B. All right, go ahead and pause the video to answer this question. All right, so we can take a look here and I can see my end behavior is going in opposite directions. So that tells me it is odd. And I see it crosses 1, 2, 3 times. So it has 3 real zeros. So my answer is C. That is the end of our lesson for 5-3, and I will see you guys next time. All right, bye.